Okay, let's read through this and interpret each one of the pieces of information that's been given to us. We're going to be working a related rates problem. So on this one, we're told that the 12-inch base of a right triangle is growing, getting bigger at 3 inches per hour. And the 16-inch height of this triangle is shrinking at 3 inches per hour. Our goal on this one is to figure out, is the area increasing or decreasing? So as we get going on this, I'm going to start labeling the sides of our triangle. Okay, I'm going to say this is our x side, as we normally think of it as, on a coordinate axis, and this is going to be our y side over here. So we know currently x equals 12 and y equals 16. But we're also told about how those are changing, right? We are told that our x's, as I've labeled them, are growing at 3 inches per hour. So that's the rate of change, dx, with respect to time. All right, so it's growing, so it's going to be positive 3, and if we wanted to include labels, it would be inches per hour. Now the other piece of information is about the upright side as it's drawn over on the right-hand side. It is shrinking, the height is, by 3 inches per hour. So that's the rate at which the y's are changing with respect to time. This one, though, is getting smaller, so we'd say negative 3 inches per hour. All right, and then our big question is the area increasing or decreasing? So the area of a triangle, you've probably seen this formula before, should be 1/2 base times height. But instead of base times height, in this case, I can represent the base as x multiplied by y, the height. So let's go ahead and differentiate this formula using implicit differentiation with respect to time. So on the left-hand side, that'll be the derivative of a is 1 with respect to time, so dA dt, and that's what we're looking for. How fast is this? Is the area increasing or decreasing? Well, what we want to know is if it's positive or negative. All right, next, what I'm going to do is bring the 1/2 along and treat these as a product rule between the x and the y. All right, so product rule says you take the derivative of the first. In my case, I'm treating x as the first, so that's going to be 1 multiplied by the derivative of x with respect to time, because x was our variable. Next, we carry along the y. All right, first derivative of the first multiplied by the second, plus you keep the first one the same, and then you multiply by the derivative of y. So the derivative of y is 1, but y was our variable, so we need to include a dy dt next to this. All right, from here, let's fill in all the information that we collected over on the right-hand side. So we can say dA dt, leaving that side alone, is 1/2. I'm going to leave the 1 alone, not going to bring it down. And then dx dt was 3. We said our y value was 16, plus our x value, x is equal to 12 on the bottom there, multiplied by dy dt was given by negative 3. All right, so now we just need to do a little bit more simplifying down and we'll know our solution. Really not that bad. This will be 1/2, then 3 times 16 should be 48, minus 36 is going to be 1/2 times 12, or positive 6. Now the units in this case work out to be in inches squared per hour. All right, and why that works out is because of our units along the way, that if we lined up, the 3 is in inches per hour, multiplied by the 16 would have been in inches. So inches per hour times inches is inches squared per hour. And something very similar is going on here with the 12. That 12 is in inches, multiplied by negative 3 would be in inches per hour. And that's why we get positive 6 inches per hour. So to answer their question, to finish this one up, is it the area increasing or decreasing? Well, the area is changing with respect to time. It's positive 6, so it's increasing. All right, hope this helps out. Gather all your information and just take your time taking the derivatives.